Today, we are looking at 12 garage tools from the 1960s that got pulled from shelves, recalled by regulators, or quietly discontinued because somebody in a government office decided they were too dangerous for the American homeowner. Most of them worked perfectly. Some of them worked better than anything you can buy right now. They were not removed because they failed. They were removed because they expected the user to pay attention. Let us get into it. Number 12. The unguarded bench grinder. Every garage in 1963 had one bolted to the corner of the workbench. A cast iron body weighing 25 pounds with two exposed grinding wheels spinning at 3,400 revolutions per minute. No spark guard, no eye shield, no wheel cover, just two stones spinning in the open air and a quarter horsepower motor that never quit. You sharpened lawn mower blades on one side and cleaned rust-off bolts on the other. The sparks hit your forearm and you did not flinch, because flinching meant moving your hand into the wheel. You learned to hold steel at the correct angle by feel, because your eyes were watching the gap between the tool rest and the stone. That gap was where fingers disappeared. Every man who owned one knew that. Every man who owned one still had all 10 fingers because he respected the machine. The Consumer Product Safety Commission required full wheel guards, spark deflectors, and adjustable eye shields by 1971. The old grinders did not get retrofitted. They got replaced with plastic-housed units that vibrate, overheat, and burn out in 3 years. The cast iron original is still running in somebody's barn right now. It just is not legal to sell anymore. Number 11. The Asbestos welding blanket. It hung on a hook next to the welding cart. A gray woven sheet about 3 feet by 4 feet that could be draped over anything flammable before the arc was struck. Wood, carpet, upholstery, fuel lines, rubber hoses. The blanket went over it, and the sparks bounced off like rain on a tin roof. It did not melt. It did not burn. It did not shrink. It absorbed heat that would set a cotton rag on fire in 2 seconds and stayed cool enough to pick up with bare hands 30 seconds after the weld was finished. Every body shop and home garage had one because it made welding near fuel tanks possible without draining the tank first. The material was perfect for the job. That was the problem. The material was asbestos, pure chrysotile fiber, woven into cloth. The same fiber that was destroying the lungs of insulation workers, shipyard welders, and brake mechanics across the country. The blankets were pulled from hardware stores by the early 1980s. The fiberglass replacements that took their place melt at lower temperatures, shed glass particles into the air, and provide about 60% of the heat protection. The asbestos blanket did the job better. It just killed you while it did it. Number 10. The 2-prong metal body circular saw. 7 1/4 inches of unguarded carbide teeth housed in a cast aluminum body connected to the wall by a 2-prong ungrounded plug. No double insulation, no ground fault protection, no blade break. The motor housing was the frame, and the frame was the handle, and the handle was connected directly to whatever the outlet was doing that day. If the wiring in your garage had a reversed neutral, the entire body of the saw became energized the moment you plugged it in. You would not know until you touched it while standing on a damp concrete floor. The shock ran from your cutting hand through your chest and out through your feet. The saw weighed 9 pounds, and the recoil from the shock meant you dropped it while the blade was still spinning at 5,000 revolutions per minute. More home electrocutions came from ungrounded power tools in the 1950s and 60s than from any other single household source. The 3-prong grounded plug became standard by 1969. The metal body circular saw did not survive the transition. It was replaced with a double insulated plastic housing that weighs half as much and feels like a toy compared to the original. The aluminum saw cut straighter because the weight kept the base plate flat against the lumber. The plastic saw wanders because there's nothing holding it down except your wrist. We traded precision for safety. Fair trade. But nobody should pretend the new one cuts better. Number 9. The radial arm saw. This was the king of the garage workshop and the most feared tool in any man's collection. A 10-inch blade mounted on a horizontal arm that pulled toward the operator on every crosscut. The blade spun toward you. The natural motion of the cut was toward your body. And if the blade caught a knot or the wood shifted, the saw did not kick back. It climbed. The blade walked up the wood and launched itself down the arm rail straight at the operator's midsection. The radial arm saw could crosscut, rip, dado, miter, bevel, and shape. It replaced 4 separate tools. Every serious home woodworker owned one between 1955 and 1975, because nothing else could do what it did in the same footprint. But the ripping function was where man got hurt. Ripping on a radial arm saw meant feeding wood into a blade that was trying to grab it and throw it back. The anti-kickback fingers wore out. The guard did not cover the full blade, and the fence was never quite tight enough to keep a longboard from wandering into the side of a spinning carbide tooth. The radial arm saw was not banned outright. It was engineered out of existence. Sliding compound miter saws replaced the crosscut function. Table saws handled the ripping. By 2005, most manufacturers had stopped making them for the consumer market entirely, not because of a recall, because the liability insurance made it cheaper to stop. Number 8. The cadmium-plated socket set. Every Craftsman and Snap-on set sold between 1945 and 1970 had a bright silver finish that was not chrome. It was cadmium. A toxic heavy metal electroplated onto steel to prevent corrosion. Cadmium plating was superior to chrome in every mechanical way. It provided better lubricity, better corrosion resistance in salt air, and a lower coefficient of friction, which meant bolts turned smoother with less rounding of the hex. The problem was the dust. Every time a cadmium-plated tool was wire brushed, buffed, or ground, microscopic particles of cadmium became airborne. Inhaled cadmium accumulates in the kidneys and lungs. Chronic exposure causes renal failure, bone softening, and lung disease. A man who spent 30 years cleaning and restoring his hand tools in an unventilated garage was breathing poison every Saturday morning without knowing it. Cadmium plating on consumer tools was phased out through the 1970s and formally restricted under hazardous materials regulations by the late 1980s. The chrome plating that replaced it chips easier, corrodes faster in marine environments, and does not turn a bolt as smoothly. But it does not give you kidney failure. That is a reasonable exchange. Number 7. The Mercury tilt switch power strip. Before solid-state electronics, the surge protector on the workbench used a small glass vial of liquid mercury to detect power surges. When the current spiked, the mercury shifted inside the vial, broke the circuit, and cut the power. Simple, elegant. No moving parts except a few grams of liquid metal sealed inside glass. Every garage, with a compressor, a welder, and a bench grinder, had one of these strips because the equipment drew heavy current on startup, and the mercury switch handled the inrush without tripping. Mechanical breakers would pop every time the compressor kicked on. The mercury switch absorbed the surge and stayed closed. The problem arrived when the glass broke. Mercury spilled onto the workbench, rolled into cracks in the concrete floor, and vaporized slowly at room temperature. Mercury vapor is odorless and invisible. A single broken vial in an enclosed garage could produce toxic vapor concentrations for weeks. The man working in that garage every evening after supper had no idea he was being poisoned until the tremors started in his hands and his short-term memory began to fail. Mercury switches in consumer products were banned through a series of state regulations beginning in the early 2000s. The electronic surge protectors that replace them are faster, cheaper, and contain nothing that will destroy your nervous system if you drop one. This is one case where the replacement is better in every single way. Number 6. The lead body hammer. A soft-faced mallet with a head cast from solid lead. 2 pounds of dense gray metal on a hickory handle, used for striking surfaces that could not be dented by steel. Chrome bumpers, machined bearing races, aluminum engine housings, brass fittings. The lead head absorbed the impact, deformed slightly on contact, and left 0 marks on the workpiece. Every auto mechanic had one. Every machinist had one. Every man who worked on his own car kept one in the bottom drawer of the tool chest because nothing else could seat a bearing without damaging the race. The lead did the job because it was softer than everything it hit. The problem was the lead dust. Every impact sent microscopic particles into the air. Every deformation of the head left residue on the workpiece and on the hands of the user. A mechanic who used a lead hammer 3 times a week for 20 years had blood lead levels that would trigger a medical intervention today. Lead body hammers are still manufactured for industrial use, but have been largely replaced in consumer markets by dead blow hammers filled with steel shot and covered in polyurethane. The dead blow does not mark surfaces either, but it bounces. The lead hammer did not bounce. It hit and it stayed. That difference matters when you are seating a press fit bearing in a tight bore with no room for a second strike. Number 5. The carbon tetrachloride parts washer. A steel tray with a hand pump and a reservoir filled with carbon tetrachloride. The most effective degreaser ever manufactured for home garage use. One spray dissolved 40 years of baked-on engine grease in under 30 seconds. Gaskets, carburetors, valve covers, transmission parts. Nothing stayed dirty when carbon tet hit it. The solvent was sold over the counter at every hardware store and auto parts shop in America through the early 1960s. A gallon cost less than $2 and lasted 6 months of weekend use. It evaporated clean, left no residue, and did not attack rubber seals or plastic gaskets the way modern solvents do. The problem was the vapor. Carbon tetrachloride is a potent hepatotoxin. The fumes cause liver damage at concentrations well below what a man could smell. A mechanic working over an open tray of carbon tet in a closed garage on a winter evening was destroying his liver with every breath. Acute exposure caused nausea, confusion, and in severe cases, fatal liver necrosis within 72 hours. The solvent was banned for consumer sale by the Environmental Protection Agency in 1970. The replacements, mineral spirits, and water-based degreasers take 5 times longer to cut the same grease, require scrubbing, and leave residue that has to be wiped clean with a separate rag. The carbon tet did the job in one pass, but the one pass was slowly killing the man doing it. Number 4. The open flame soldering iron. Not electric, not butane. A solid copper tip on a steel shaft, heated by an open propane flame on the workbench. The tip sat in the flame until it glowed dull orange, then got pulled out and applied directly to the joint. Every plumber, electrician, and shade tree mechanic owned one because it delivered more heat to a larger joint than any electric iron could match. The open flame sat unattended on the workbench while the man worked. Rags, soaked in solvent, sat 3 feet away. Sawdust from the morning's project covered the floor. The garage had no fire suppression, no smoke detector, and 1 exit. The combination of open flame, volatile chemicals, and combustible dust in an enclosed wooden structure was a fire waiting to happen. Garage fires caused by open flame soldering equipment accounted for a significant percentage of residential workshop fires reported through the 1960s. The electric soldering iron and the self-igniting butane torch eliminated the standing flame. They also eliminated the ability to heat a half-inch copper tip to the temperature needed to sweat a 3/4-inch pipe joint in 1 pass. The electric iron takes 4 minutes to reach temperature. The open flame took 40 seconds. Speed cost safety. Safety cost speed. Pick one. Number 3. The spring-loaded engine valve compressor. A C-shaped clamp with a lever arm and a heavy coil spring, designed to compress valve springs during engine headwork. The tool stored enormous mechanical energy in the compressed spring. If the keeper slipped, if the lever was released too quickly, or if the clamp was positioned off-center by even a 1/4 inch, the spring launched the valve retainer at the speed of a slingshot, directly at the face of the person holding it. Emergency rooms in the 1960s documented thousands of facial lacerations, broken teeth, and eye injuries from spring-loaded valve compressors. The tool required both hands to operate and left no hand free to shield the face. The man doing the job was leaning directly over the work surface with his eyes 12 inches from a loaded spring under 200 pounds of pressure. The modern overhead valve spring compressor uses a threaded screw mechanism that applies force gradually and holds the spring in place without stored energy. It is slower, it requires more setup, and it has never launched a valve keeper into anybody's eye socket. The old tool was faster. The new tool is the reason you can still see. Number 2. The unvented kerosene torpedo heater. A horizontal cylinder that burned kerosene and blasted heated air directly into the garage through an open flame combustion chamber. No chimney, no exhaust vent, no fresh air intake. Just a fan blowing air over a burning fuel stream and pushing the heated exhaust into the workspace. Every unheated garage in the northern states had one from November through March. The heater turned a freezing workshop into a comfortable workspace in under 10 minutes. The man could work on the car, sharpen tools, or build furniture without his hands going numb. The kerosene was cheap, the heat was instant, and the carbon monoxide was invisible. An unvented kerosene heater in a closed 2-car garage could produce lethal concentrations of carbon monoxide in under 90 minutes. The symptoms mimicked fatigue. The man felt tired, sat down on the shop stool, closed his eyes, and never opened them. The fire department would find the heater still running and the garage door still closed. Unvented combustion heaters for enclosed spaces were restricted through building codes and consumer safety regulations throughout the 1970s and 80s. The vented forced air heaters and electric radiant panels that replace them take longer to heat the space and cost more to operate, but they do not fill the room with a gas that kills without warning. Number 1. The all-metal steering wheel puller with no safety chain. A 2-jaw puller with a center screw designed to remove pressed-on steering wheels from tapered steering columns. The tool applied hundreds of pounds of force through a threaded center bolt pressed against the end of the steering shaft. When the taper broke free, it broke suddenly. The steering wheel, the puller, and the center bolt released as a unit with the stored energy of a compressed spring, launching directly at the chest and face of the man sitting in the driver's seat. There was no safety chain, no retention strap, no shield. The man positioned himself directly in the line of fire because there was nowhere else to sit while turning the center bolt. The release was violent, instantaneous, and completely unpredictable. The steering wheel came off the column and hit the man in the sternum hard enough to crack ribs. The modern steering wheel puller uses a threaded bridge design with a safety brace and a controlled release mechanism. The taper breaks gradually. The wheel lifts evenly. Nobody gets hit in the chest with 15 pounds of steel and hard plastic traveling at the speed of a punch. 12 tools. Every one of them did the job it was designed for. Most of them did it better than anything available today. And every one of them was removed from the market because the risk of using it exceeded what a modern legal system would tolerate. These tools were not built for careless men. They were built for men who understood that a machine does not care about your safety. You care about your safety. The tool just works. We replaced personal responsibility with product liability. We traded skill for safety features. And we called it progress. The tools are gone. The garages are quieter. And the man who could fix anything with 12 items and a Saturday morning is disappearing with them.